Hi friends, welcome to SriSai IT Hub. In this video of Core Java Programming, we are going to discuss the following topic: Zone Offset class in Java Programming. So coming to Zone Offset class. So this class is available in java.time package, and using this class we can work with fixed zone offset with respect to UTC time zone. So what is UCT? It is a coordinated universal time. So it is available in java.time package zone offset class. It is a final class and it is inherited from ZoneId class. Right. So if we see the description of the class, we have some important methods to work with the zone offset. So java p public java.time.ZoneOffset. So open the command prompt, go to your working directory and issue this command. Right. So java.time.ZoneOffset class. So here we have some important methods to work with zone offset. So we have some static methods. We also have some non-static methods. So let us try to understand all these methods one by one. So it provides three final data members: zone offset, UTC, minimum, max. So what is a minimum and maximum zone offset which is supported by Java? And we can make a zone offset using off method by passing the zone offset ID, and using get ID we can get the zone offset ID. Get rules, we can get the zone rules which are applied to a particular zone offset. So we have static methods using which we can create a zone offset. Off hours, using hours, minutes, off, hours, minutes, seconds. And we can also get total number of seconds for a particular zone offset. And then we can also create a zone offset using off total seconds. So we have to pass the seconds, we'll get the zone offset object. And we can also compare one zone offset with another zone offset. It returns greater than 0 if first zone offset greater than second zone offset less than 0, if a first zone offset less than second zone offset, and equals to 0 if both the zone offsets are equal. Right. So here, taking the zone offset ID. So we have zone offset IDs minimum and maximum. So minimum is minus 18 hours and maximum is plus 18 hours. So these are the IDs which are supported by zone offset as string. You can take Z, which is coordinated universal time, whose zone offset is, it goes like this. So it is 0 hours and 0 minutes. And we can also use plus H plus HH or plus HH colon MM minus HH colon MM plus HH MM minus HH MM plus HH colon MM colon SS minus HH colon MM colon SS plus HH MM SS minus HH MM SS. So these are the supported zone offset IDs which can be passed to off to get a off static method to get an instance of zone offset. So let us try to demonstrate this with a small program. Zone offset class, Java zone offset class, example 1. So take a new page. First write comments at the beginning of the program. Import java.time package. Take the main class with the main method. Right. So first we'll create a zone offset object reference ZFT using zone offset dot static final variable UTC. So print ZFT, its ID, get rules, get total number of seconds. So zone offset will be 0 hours 0 minutes, so total number of seconds will be 0. So save this program, come to the command prompt, and then compile the program. Java C, Java zone offset class example 1.java. Compile it and then run it. So for UTC, this is the object reference Z, ID is Z. So the zone rules are current standard offset Z, and total number of seconds, offset seconds are 0. So you can also use minimum and maximum here. I'll use min, save it, recompile, and then run it. So this is minus 18 hours and its offset seconds are 64,800, and zone rules are current standard offset, which is minus 18 hours. Similarly, we can also take max. Save, recompile, and run. So for max, it is plus 18 hours. So minus 18 hours to plus 18 hours, these are the minimum and maximum zone offsets which are supported by Java programming. Its total number of elapsed seconds will be, with respect to 0 hours 0 minutes, it will be 64,800. And zone rules is current standard offset, which is plus 18 hours. Right. So now let us create our own zone offset by passing zone offset ID. So for this, I'm going to use a static method. So zone offset dot off static method plus 530 hours, which is for India, Calcutta. So store that in a reference variable ZFT, print zone offset object reference ID, get rules, and get total number of seconds. So total number of seconds will be calculated for 5 hours, okay, and 30 minutes, okay, and then its corresponding seconds. So plus 530 hours ID, zone rules, current standard offset is plus 530, and this is the total number of seconds, which is plus 530 hours from 0 hours 0 minutes. Right. So next, let us take of total seconds. So I'm going to create a zone offset object reference using a static method from zone offset class of total seconds 19,800, which is for India, Calcutta, plus 530 hours. So print ZFT, ID, and rules. Right, so save this, recompile, and run. So plus 530 hours is the ID, and rules is current standard offset plus 530 hours. Right. So next, coming to, we'll take another zone offset, okay, right, with respect to hours, minutes, seconds. First, so first one goes like this. So zone offset ZFT is equals to zone offset dot off hours 5. So for 5 hours, what is the zone? Print ZFT dot get ID and its rules. Save it, recompile, and run. So plus 5 hours is the ID, and rules current standard offset, which is plus 5 hours. So next, we can also create a zone offset using off hours static methods by passing 5 hours and 30 minutes. So save it, recompile, and run. So plus 530 hours, zone rules, current standard offset, which is plus 530 hours. So ID is plus 530 hours, and also rules also current standard is plus 530 hours. Now I'm creating a zone offset using of hours, minutes, seconds. So 5 hours, 30 minutes, 45 seconds. Okay, right. So recompile and run. So plus 530 hours, 45 minutes, and the zone rule is current standard offset, which is equals to plus 530 hours. Right, so this is how we are supposed to use the three static methods of hours, minutes, of hours, minutes, seconds. Now let us perform comparison of two zone offsets. So first I'm taking zone offset, ZFT1 is equals to zone offset dot of hours, minutes, 530 hours. Similarly, okay, I'm taking first one as 830 hours and second one ZFT of hour, minutes, 530 hours. So I'm comparing ZFT1 830 hours compared to ZFT2 530 hours. So first zone offset is bigger than second zone offset, so it will return plus 1, or it will return the difference of seconds. Okay, so it will return greater than 1, which is difference of seconds. Okay, so ZFT2 compared to ZFT1, so here it is less than, it will return a value less than 1, which is again difference of seconds. Right, so next what I'm doing is I'm taking ZFT1 is equal to zone offset dot of hours, minutes static method 530 hours. Similarly ZFT2 also 530 minutes, 5 hours 30 minutes. So now make the comparison. So ZFT1 dot compare to ZFT2, so both are same, so it will return 0, which is number of seconds, difference of seconds. So recompile and then run it. So we got 830, 530, so minus 10,800 plus 10,800 and then 0. Right, so in the first case, yeah, right, so yeah, so here we are getting it as, yeah, compared to of ZF2, so we are getting as less than 1, greater than 1. Okay, so less than 1 and greater than 1. So difference of seconds it is giving. So generally it will compare with values, first value greater than second value, then it will return greater than 1. If first value is less than second value, it will return less than 1. But since this is zones with respect to hours and minutes, it is returning the difference of seconds. Right, so first minus second and then second minus first. So this is how we are supposed to work with zone offset class in Java programming, which belongs to java.time package. Thank you for watching this video. Do like, comment and share this video, and also subscribe to the YouTube channel Sri Sai IT Hub. Have a nice day.